Okay, this is dissociation of acids and bases, and let's remember that we said that all acids do is produce hydrogen, and bases, all they do is produce hydroxide, OH minus. So there's no big mystery here. So it says please write dissociation equations for the following acids, meaning they're all going to produce H+. And remember that these are ionic compounds. They dissociate right down the middle. So HCl has only one H and one Cl minus. Let's be careful. This is what's known as a polyatomic ion. And you'll find them on the list of polyatomic ions that I included elsewhere. Not here, apparently. Sorry about that. So, and if you're wondering where the division occurs, remember that bases produce hydrogen. So you're going to divide this in a way that makes it produce hydrogen and something else. This one has got two hydrogens. You guys know how this works. So when it dissociates right down the middle, 2H+ and SO4, 2 minus. And this one as well. It's got 3 H+s and PO4, 3 minus. Okay? These are bases, which means they produce OH. Notice they all have it. So we're going to dissociate it right down the middle. Sodium hydroxide dissociates into sodium hydroxide. Potassium hydroxide dissociates into potassium and hydroxide. Barium hydroxide dissociates into barium, and you see it right there, 2 hydroxides. And finally, aluminum hydroxide dissociates into aluminum and 3 hydroxides. Okay? All right, this one says, please fill in the blanks for the following neutralization reactions. Let's remember that a neutralization reaction is a double displacement reaction where AX and BY are going to produce BX and AY. And the AY is always water. AY is this and this. That's the A and the Y. So what's left is BXB being Na and X being Cl. Okay? That means we have an acid and a base react to produce a salt and water. And that's all we do. So I tried to indicate that there were some coefficients going on here, but don't worry about it if you don't get them. All right, so this is our base. This is our BY. That means this is going to be AX. That's going to be BX. And this is going to be AY. So if this is B, this must be X. So that's SO4, and it's coming from an acid, and that's our A. And since you've seen this acid before, it comes from right here, H2SO4. If you don't get it, I understand. All right? We should balance this just because, but I think we're already in good shape. Except for the fact that there are 2 oxygens. So let's put a 2 here. Okay? That's all we do. So here is AX, BY, and our products are BX and AY. And by now you know that the AY is always water. This is B, so that's going to go right there, and that's why there is a 2 here, because barium hydroxide has 2 hydroxides. And that's it. We should balance it because there are 3 bariums here, so let's put a 3 here. And that means that there are now 3 oxygens, plus there's 3 hydrogens here. That's a total of, well, there's 2 phosphates here, so let's put a 2 here. I believe that takes care of it, except that makes, now we have 6 hydrogens here and 6 here, so let's put, well, that's 12, let's put a 6 there. Okay? And the last one, here is our AX. Here is our BY. You know that this is always going to be water. AY. So what's our BX? There's our B, there's our X, AL. And that has a charge of 3 plus, and the X is NO3. Charge of -1, so we'll do our drop and swap. And let's balance. So because there are 3 nitrates over here and only 1 here, let's put a 3 here. All right, and I believe that does it. Yep. All right, so there you go.